Now, today we are going to see time-independent Schrodinger's wave equation in the quantum mechanics. Time-independent Schrodinger's wave equation. In the previous session, we have seen what is a wave function and what is the Schrodinger's wave function. The wave function, as I said you in the earlier sessions, the wave function or the wave function psi, it is very much essential to go with the further derivations in the quantum mechanics. So as discussed previously, what were the essential conditions in the quantum mechanics which led to all these developments is a wave nature of a particle. That means every moving particle is associated with a wave having a wavelength of lambda is equal to h by p. That wavelength is called as a de Broglie wavelength, or matter waves are the waves which are moving with a velocity v having a wavelength of lambda is equal to h by p. That led to Heisenberg's uncertainty principle, where he has assumed that, where he has said that delta p delta x is greater than or equal to h by 4 pi. Now all these things, significance of the Heisenberg's uncertainty principle states that instead of looking for the exact position and momentum of a particle, it is the probability that we can see the probability of finding a particle in a given space, or probability of finding a particle, that means probability of a position of a particle or probability of finding a momentum of a particle. So we go with the probability function. So it led to the wave function. The wave function determines the probability density, normalization condition, and what are the properties of wave function. All these things we have seen in the previous sessions. With the knowledge of those things, we are going to see the time-independent Schrodinger's wave equation. The general differential equation of a wave traveling in x direction with a velocity u having a wave function psi is given by. Thus, what is psi? Psi is a wave function associated with a particle. Now we are going to see how the wave independent equation has been derived by the scientist Schrodinger's. That equation is known as a Schrodinger's wave equation, and which is independent of time. Therefore, it is said to be a time independent Schrodinger's wave equation. Now we are going to see the general differential equation of a wave traveling in x direction with a velocity u having a wave function psi is given by d square psi by dx square is equal to 1 by u square into d square psi by dt square. Now you can see here in this equation, psi is a function of x as well as function of a time. That means the position is being changing. The wave function, the particle associated, wave function is associated with the particle. So it is related, it is a function of x as well as time t. So the general solution of this equation 1. What is equation 1? The d square psi by dx square is equal to 1 by u square into d square psi by dt square. This is the equation 1, which is a general differential equation moving in x direction with a velocity u is given by this equation. The general solution of this equation 1 is given by psi as a function of x and t. As I said, as I told you, psi is a function of x as well as t. Therefore, psi of xt is equal to a into e to the power of I into kx minus omega t. This is equation 2. Now, as I told earlier, this quantum mechanics requires the probability functions, complex numbers, analysis of a little bit of mathematics is also required to understand these concepts. So, general solution of equation 1 is psi is a function of x and t is equal to a into e to the power of I kx minus omega t, where a is a constant amplitude or k is a wave vector and omega is the angular frequency. So what is a wave? The same equation I have written here because we have to differentiate this. Psi of x comma t is equal to a into e to the power of I kx minus omega t. This is the equation 2. Differentiating this equation with respect to t, we get first, this equation 2 has to be differentiated 2 times. So first we will take the first d psi by dt with respect to t. We are going to deal with the differentiating with respect to t. So d psi by dt is equal to a into e to the power of I kx minus omega t into minus I omega, because it is a function of t. So omega t is there, I omega t. So we can take it as e to the power of I omega t. You get it as differentiate, first order differentiation, you get minus I omega into a into e to the power of I kx minus omega t. Now again differentiate d square psi by dt square is equal to a into e to the power of I kx minus omega t minus I omega, because your first differentiation you get I omega, next again you differentiate, you get it as minus I omega, so it becomes minus I omega square. As you know, I square is taken as minus 1, substituting the value of 1 minus 1 over here, so you are writing as d square psi by dt square is equal to minus of omega square into psi. Why we have taken this psi as come into picture is, from equation 2 we know that a into e to the power of I kx minus omega t, we are taking that as a value of psi, so the whole value except I square minus I whole square become I square into omega square. I square is nothing but minus 1, so minus is there, omega square is there, rest of a into e to the power of I kx we have taken it into psi. Therefore this is the equation 3. Next, substitute 3 in equation 1. Now if you look at this, substitute equation 3. What is d square psi by dt square? Substitute the value of this equation 3 into the equation 1. What is equation 1? We have taken initially the general differential equation of the wave traveling in x direction is d square psi by dx square is equal to 1 by u square into d square psi by dt square. Substitute the value of equation 3 d square psi by dt square into this equation 1. You will be getting the equation as d square psi by dx square is equal to minus omega square by u square into psi. This is equation number 4. Now we know that omega is equal to 2 pi nu. This is a general equation. Omega, angular frequency is equal to omega is equal to 2 pi nu, that is equal to 2 pi u. Nu can be written as u by lambda, where u is the velocity of the wave and omega is the angular frequency. Now from this equation, u square by omega square by u square, taking omega is equal to 2 pi u by lambda. So squaring that equation, omega square by u square is equal to 4 pi square by lambda square. So this becomes equation 5. Now what is de Broglie hypothesis? As I said starting of the session, everything deals with the de Broglie's, Heisenberg's uncertainty principle, probability function and wave function psi. So now having the de Broglie's hypothesis, lambda is equal to h by p, we know that instead of lambda you are giving as h by p. Substituting the value of lambda is equal to h by p in equation 5, you are getting omega square by u square is equal to 4 pi square into p square by h square. This is the equation 6. Now what is the total energy? You all know that total energy is a sum of potential energy as well as kinetic energy. This is the equation which you are learning right from the beginning of your lower classes. So total energy E is equal to kinetic energy and potential energy. Therefore E is equal to half mv square plus v. V is the potential energy. So multiply and dividing this half mv square with m by numerator and denominator by m. So we are getting as m square v square. We know that p is equal to mass into velocity, momentum is equal. So substituting m square v square as p square by E is equal to p square by 2m plus v. V is the potential energy, p square by 2m is the kinetic energy. So we are writing the total energy expression E is equal to p square by 2m plus v. Rearranging the terms in this equation, we are getting p square is equal to 2m into E minus v. Just rearranging, bring this plus towards the right hand side of the equation towards left hand side, and rearranging the terms, you are getting p square is equal to 2m into root 2m into E minus v. Now substituting the value of p square in equation 6. Now if you see the value of p square into the equation 6. What is equation 6? Omega square by u square is equal to 4 pi square p square by h square. Substituting the value of p into this equation 6, you are getting omega square by u square is equal to 8 pi square m by h square into E minus v. Substitute this equation in 4. What is equation 4? We will see once again. This is the equation 4. D square psi by dx square is equal to minus omega square by u square into psi. Substituting this in value of in equation 4, we are getting d square psi by dx square is equal to 8 pi square m by h square into E minus v into psi. So rearranging the terms, bringing all the right hand side to the left hand side, you are getting d square psi of x and t, which is psi is a function of x and t. Therefore d square psi, which is a function of x and t by dx square plus 8 pi square m by h square into E minus v into psi equals to 0. This is the time independent Schrodinger's wave equation in one dimension, because we are taken in only one dimension, that is x. Therefore, this is a time independent Schrodinger's wave equation in one dimension. Hope you all understand, and thank you.